Hello again. This is Math 2233 coming to you from the College DuPage, and this lecture is the conclusion of more 3D surfaces, cylinders, and quadrics. And as always, I encourage you to be an active learner while you watch this video. When last I left you, you were working on this problem to use traces to sketch this surface z equal 4x squared plus y squared. You probably finished it, and if so, congratulations. If not, I'll give you some more time right now. You know what to do. Let's see how you did. Okay, this is the equation that we had. So if we look at traces in the plane where z is equal to k, we just put k where z is. And we get this is 4 x squared plus y squared equals k, and those are going to be ellipses. Now notice that k can't be negative because z is the sum of two things that are being squared. But these are going to be ellipses, and as z gets bigger, the major axis of the ellipse gets bigger, and the ellipse gets bigger as it goes up. Okay, let's look at the planes x equal k. Now, if you're looking at k being greater than 0, you get z equal y squared plus 4k squared, and that is going to be these parabolas in the plane. And if you look for k to being less than 0, you still square it, and so you have the same kind of thing for less than. So you see you get ellipses going this way, you get parabolas going this way. And last but not least, we look at y equal k. And these are parabolas, so we put a k there. And this is, now this is a slightly different shaped parabola, but that's okay. This is z equal 4 x squared plus k squared, so we get these. So you see, when you connect all of these things, these traces, and put some wallpaper around them, then what you realize is that you have something that goes up as parabolas, but each cross section this way is an ellipse. And we'll talk about a name for this in a bit. Now here's another problem for you to consider. Sketch the surface z, which is like it was in the last one. Now this is equal to y squared minus x squared. So we have a negative going here. You know what to do. Let's see how you did. Okay, so the vertical traces, we're letting x equal k. That means that z, here's the formula that we had down here, so z is y squared minus k squared. So that is a parabola, and since both of the coefficients are positive, it is opening up. Now, if we do the other vertical trace, we also are going to get a parabola. Again, this is what we're using. But now when you let y equal k, this is z equals minus x squared plus k squared, so it opens downward. And so that's what we have. And then if we look at z equal k, we get y squared minus x squared equals k. So you see that this is going to be hyperbolas that you get that way. So if we move these to their correct planes, then this is going to be the one where x is equal to a constant. So you see you have parabolas there that are opening upward. If we look at traces in the y equal k, we have parabolas that are opening downward. So you want to think about, you're going to be taking these together, and here we have hyperbolas. And so when we put all three of these together and put wallpaper, you see we have this. Looks like a saddle, doesn't it? So this is two views of the surface z equal y squared minus x squared, and this is called a hyperbolic paraboloid. You should note that if you're going along the y-axis, this ends up being a minimum point, and if you're going along the x-axis, that ends up being a maximum point, and we'll talk about that more later. Here's another one for you to do. Sketch the surface x squared over 4 plus y squared minus z squared over 4 is equal to 1. You know what to do. Let's see how you did. Okay, the trace in any horizontal plane, z equal k, is this ellipse. Now we're letting z equal k, and here was the equation that we have. So z is equal to k, so we get k squared over 4. And that means that what you get is you get an ellipse. And so you have an ellipse in those x's. But the traces in the xz and yz planes are hyperbolas. Here you let y equal if you take k to be, if y to be 0 and x to be 0 here, you can see that these are hyperbolas, so you get hyperbolas that look like that. And so if you put that all together, you have ellipses here, and you have hyperbolas there, and so what happens is that you have a figure that looks like this, and we call this a hyperboloid of one sheet, meaning it's just one piece of paper that's needed to, or one sheet is needed to do that. It's all one thing. It's a continuous surface. You could crawl all over that, and so that's what we have here. Now, the idea of using traces to draw a surface is employed in three-dimensional graphing software. In most such software, traces in the vertical planes x equal k and y equal k are drawn for equally spaced value of k, and parts of the graph are eliminated using hidden line removal. That's actually kind of a neat software trick. Table 1 shows computer drawing graphs of the 6 basic types of quadric surfaces that can happen that are in standard forms. Now, all surfaces are symmetric with respect to the z-axis in this table. But if a quadric surface is symmetric without a different axis, its equation changes accordingly. Also, you can rotate these and translate these as well. So be mindful of that. And you will have some exercises that will have you doing those kind of things. Okay, we've talked about an ellipsoid here. We did an example where it looked like this, and the traces are all ellipses, and if A equal B equals C, then it is a sphere. So we did an example of an ellipsoid. We also did an example of the thing called an elliptic paraboloid. Horizontal traces are ellipses, and vertical traces are parabolas. The variable raised to the first power indicates the axis of the paraboloid. So we did one of those. We also did one of these. This is the hyperbolic paraboloid. Horizontal traces are hyperbolas. Vertical traces are parabolas. And this is the case where c is less than 0. It will go the other way. If the saddle will be mounted the other way and going this way, if you were to take c being greater than 0. We also did a hyperboloid of one sheet. So horizontal traces are ellipses, vertical traces are hyperbolas, and the axis of symmetry corresponds to the variable whose coefficient is negative. We did not talk about cones, but you should study them here. And the difference between this and this is you don't have the 1. And also the z is on the other side, so the horizontal traces here are ellipses, and the vertical traces in the plane z equal k and y equal k are hyperbolas if k doesn't equal 0, but are a pair of lines if k is equal to 0. And you can see the pair of lines is the degenerate case there. We haven't talked about a hyperboloid of 2 sheets yet. But now I'm asking you to identify and sketch this surface here. 4, and you should use that table for your reference from your notes. 4x squared minus y squared plus 2z squared plus 4 is equal to 0. You know what to do. Let's see how you did. Okay, so here's the one that we're doing. We divide all the way through by minus 4 and compare it with table 1, and we realize this represents a hyperboloid of 2 sheets, one of the 2 that we didn't do. The only difference being in this case that the axis of the hyperboloid is the y-axis. We look at the traces then in the xy and yz planes, and we get hyperbolas. This one and this one. Now the surface has no trace in the xz plane, but traces in the vertical plane y equal k when k is greater than 2. are these ellipses. This ellipse, which can be written in this way, and that is when the absolute value of k is greater than 2. So you see you've got two branches of this hyperbola. And so when we use those traces, we get this picture. And this is, again, a hyperboloid of 2 sheets, because you would need 2 sheets of infinite length to cover this. And because you can't go continuously from one sheet to the other. So you need 2 sheets. Let's look at another one. Here, you're to classify the quadric surface. X squared plus 2z squared minus 6x minus y plus 10 is equal to 0. And when you look at the relationships of the x's and the y's, or let's just say the x's, and the y's, you observe that this is probably translated somewhere, and you have to be aware of that shift. Okay, so you know what to do. Let's see how you did. Okay, so first we're going to complete the square on the x, and that means we're going to have to add 3 squared to both sides, and then we subtract the 10, so we move things around, and we get that this is y minus 1 is equal to x minus 3 whole squared plus 2 z squared. So you see this is shifted 1 unit in the y direction and 3 units in the x direction, and so that gives us a vertex. And comparing this with the table, we see that this is an elliptic paraboloid. However, the axis is parallel to the y-axis, and it is opening up because this is positive and this is positive. So the vertex is at this shifted point, and the traces are ellipses, this one in the plane y equal k, and in the xy plane this is the equation, and so that's a parabola. So this is the paraboloid sketched. So you see it's an elliptical paraboloid. Now, examples of quadric surfaces can be found in many places in the world. We talked about some of them earlier, but in fact the world itself is a good example because it's often considered to be a sphere, the shape of the Earth. It's considered to be a sphere, but more accurately it's an ellipsoid because the Earth's rotation has caused a flattening at the poles. Circular paraboloids are used to collect, and we talked a little bit about this, light, sound, radio, and television signals. In a radio telescope, for example, signals from distant stars that struck the ball are all reflected to the receiver at the focus and therefore amplified, and that makes them easier to pick up these weak radio signals. The same principle applies to microphones and satellite dishes in the shape of paraboloids. And we did say cooling towers for nuclear reactors are often divided in the shape of hyperboloids of one sheet because they're very structurally stable. Pairs of hyperboloids are used to transmit rotational rotation between skew axes. That's kind of a mechanical engineering thing. And this is also covered in some exercises that we may look at. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself and of each other. God bless you all.